Hey everyone, welcome back to our channel all about BI. In this session, I'm going to talk something about partitioning or parallelism in copy activity. Whenever we talk about partitioning, we all know about mapping data flow partitioning techniques, right? Round robin or key based partitioning and all. It's quite easier with mapping data flow, but in case you want to do something similar to partitioning from an on-prem source, right? For example, you have a server, SQL server, which is in an on-prem server. In that case, you cannot use mapping data flow because mapping data flow doesn't support connecting to an on-prem SQL server, right? So in that scenario, in case your table is so large and you want to bring the data to data lake or blob storage with some partitioning technique, how can we leverage copy activities partitioning? That's what I'm going to tell in this video. With copy activity, whenever your source is a table, okay, SQL table, you will see this option, partition option, okay. For other kind of data stores like file and all, you will not be seeing this. So by default, copy activity leverages the type of source. If it is a table based source, it can make use of partitioning technique, okay. So what option is given is there is a partition option. Whether you don't want to apply any partitioning, you can choose none, or from your table, if you already have some partitions created on the table, you can leverage that, okay. In case you don't have physical partitions on the table, you can make use of dynamic range, okay. So this is the partition option, and followed by that you have couple of options: partition upper bound, partition lower bound, partition column name, okay. Column name you can choose by yourself based on whatever column you think that partitioning can be leveraged better. You can choose that. Normally an id column or any column which doesn't have a diversified data, okay, where you can easily create partitions and all. So based on that you can choose. If you leave it right, it will automatically choose one of the columns, okay. So this is partition column name, upper bound and lower bound. So how does this work is, I have a id column, or I have some type column, maybe type of the car, type of the product, something like that, right? I hardly have ranges, in the sense, in my type column or id column, if I have values like numbers, numeric values, right? What I can do is I can choose upper bound and a lower bound. So how does it work is, in case your id column is going to bring 1 to 100 and I am choosing 10 as my lower bound, 10 as my lower bound and 80 as my upper bound. So in case I am giving like this, you are going to partition based on an id column, and your upper bound is 80 and lower bound is 10. What does that mean is, how much ever rows are below 10, how much ever rows have the id column below 10, they are going to be considered as one partition, okay. And then how much ever rows you have greater than 80, it will all become one partition. And then between 10 to 80, it will be creating in chunks. The partition can be from 10 to 20, 20 to 30, 30 to 40, like that it will be creating partitions, okay. But that again depends on one more settings. It's nothing but degree of copy parallelism. So here you can give a number. Based on that, it will be binning. It will be making the split actually. So in our case, 10 to 80, if you want to split it into 10 values per bucket, right? 10 id values per bucket, right? You can give 10 here, okay, like that. This degree of copy parallelism determines number of threads that are used for the partitioning, okay. It just speeds up or optimizes the copy activities performance. All right, so these are all have to be accounted when you are dealing with parallelism in a copy activity. So the first condition is it has to be a SQL based source, and then you have to have a column that will be used in the partitioning, and these options are all optional. Even if you leave it, it is going to take its own value internally, and it's going to create partitions, okay. In my case, I'm just leaving this empty, all empty, and then In the settings I just gave 47 before, just to check whether it is actually taking this number and creating those many files or not. No, if I leave this, if I don't mention anything, I will run this. I have a table, I have my SQL table source. It's a quite small table. Okay, I don't have much data and all. And then this is my table data. So based on product category ID or product ID, we can create partitions, right? So I have executed this copy activity with the default settings, or on the other hand, I would say I haven't chosen anything in the copy activities. Partition column name, upper bound, lower bound, I also didn't give any degree of copy parallelism. So if you look at the output, right, I will show you the output. It has created 4 files based on my source data. It has created 4 files. So what it has internally done, it has taken the source data, it has split that into 4 different files, and it has copied into my data lake. Okay, as you can see here, my sales table, inside that I have a product ID column. It has considered that column for creating the partitions. Okay, as you can see the naming convention here, right, it starts with 0 and then first partition, second partition and third partition. And here if you notice one more thing, from NA to 760, so this 760, 920, 920, 840, these are all nothing but these are the product IDs. In the product ID column you see these many values. Okay, so ultimately it's easy to understand. From some number, it has sorted internally from a particular number which is the lower bound. From that number to 760 it has created one partition. From 760 to 840 it has created another partition, and 840 to 920 it has created one more partition, and the last partition is 920 and above. So from NA to 760, 760 to 840, 840 to 920, 920 to 920 and above. So this is how it has internally partitioned. So in case you want to bring a very bigger file from on-prem, you can leverage this partitioning option. It doesn't require much inputs from us. In case you want to break it into further number of partitions, right, you can make use of this degree of copy parallelism. You can give 10 or something. It can make use of 10 threads, and it will create 10 partition files. But it doesn't guarantee it has to create those many partitions alone. So if I say I'm using 20, I'm not giving any other option now. Lower bound, upper bound and all I'm not giving. I just mention in the settings degree of copy parallelism is 20. Let us see how it works. Copy activity is done now. Let us see how many files were written. See here, 14 files. So it doesn't, degree of copy parallelism, it doesn't guarantee those many threads have to be used for creating the partitions. It depends on the data. In my case, I'm using an adventure works table. It's not having huge data and all, so it will internally decide how many threads to use. Okay, so it has used 14 threads even though I have given 20, right? So just leverage these options and try to bring the data from your on-prem to data lake. From there onwards, once you have your data in data lake, you can do whatever transformation you want using mapping data flow. So one issue with mapping data flow is it doesn't support on-prem based data stores, right? So in that scenario, you can make use of copy parallelism in copy activity and play with it. Okay, that's all for this video. If you have any question or if you have any suggestions, please let us know in the comment section so that it can be useful for many. Thank you so much for watching.